rust or whatever. I don't know how it's called in English. Corrosion. If there are cables and leads, just make sure they're properly seated as well. Of course, there's a bunch of sound chips, and they're all. I've made this classification because they're different in the ways you approach trying to understand them. The dedicated chips are chips that could be bought separately and analyzed on their own, like on a breadboard, auto board, or whatever. The AY was I mentioned it a bit earlier. The SAA 1099 was only used in a few very rare arcades and in the Sam Coupe kind of British computer. I don't know if anybody's heard about it. I just put that on the breadboard at home and started analyzing it. And the ubiquitous SM76 489, which again was a very small, very simple chip. There's three channels on a square and one channel only. The memory mapper, familiar to anybody here? The NES memory mappers, yeah. These are special chips that are usually only found in some cartridges. In that case, they're only found in Famicom cartridges, so the Japanese NES. The reason for the existence of mappers is a special chip because a cartridge can typically only hold so much information that the CPU on the motherboard can see. So in order for games to have more data than the typical original cartridges had, you need to have some way to switch the amount of data that is seen from the CPU. It's like switching the window. It's a bit complicated. But on top of that, there's plenty of them, like 100 or so mappers or more for the NES. I don't know them by heart. Many people are much better than I do on that front. Some of the mappers, however, especially Konami stuff, had extra sound channels with different types of waveforms on it, which is quite interesting. So they complemented, especially the Japanese system, which you have the NES, typical audio, plus the extra sound channels, and they're both getting mixed. However, the North American NES didn't have that facility. So the only way to play these things is to hook up a NES Famicom adapter and hook up a connector to strip out the sound from it. This one created, I think, I'm in the process of analyzing them. I know Keftis has done it before me, and I've chatted with him on IRC a lot recently. So this one had, if I remember, 2 channels of square waves and one saw. And this is a full FM chip with 6 channels. It's amazing. Only used in one game, Lagrange point. Namco is typically a wave channel sound chip, which is not unlike what Namco used on the arcades and Pac-Man and stuff, the kind of waveforms. Of course, there's more, but these are the most famous ones. So these chips can really only make sense in the context of the cartridge in which they were based for. It's quite hard to take them out of context and analyze them separately. So many people, especially Keftis, have used CopyNES and kind of stuff like that to write to their registers without taking them out of context, making sure they work. I/O chips, many people think the SID is a dedicated chip that only does sound. It's not true because it can scan paddles, analog paddles. It hasn't been used much. And the Pokey in the Atari was used, well, the name says potentiometer keyboard. It's really something to scan for analog input, and on top of that, it made audio. So I treat them separately. In most cases, it's exactly the dedicated one, but it would be unfair to say that they're only doing audio. The VDC, anybody knows what that means? A video display controller. I noticed that. I talked about that briefly. So these video display controllers, for many consoles, just that chip that generates the video. But in some cases, for the earlier consoles, the manufacturers just said, well, why only put video when you could have audio as well? They're driven by most of the same plots. So the T on the Atari 2600 does that. It does the video and the audio. This is the chip in the Odyssey. VIC-1 for the VIC-20, 10 in the obscure Commodore machine, Commodore 16 and Commodore Plus 4. The UVI in the very more obscure LaserVision or Arcadia 2001. Anybody has ever had one of these? No? In Europe, they were called differently. You have the CPUs. Of course, the two Nintendo 8-bit machines had their audio already generated by the CPU itself. So it's quite, I haven't seen any other audio chip like that were tied to the CPU as much as they are. So there comes a time when you need to record the audio out of those things, and what you do is that the chips, if you can take them out of context, it's even better because you can write in the language of your choice, and if you use an Arduino or MIDI box or whatever parallel port on a PC, it's more, that you tinker electronically with, it's much more easier than having to do a gizmo like that, which is basically, this is my rack mount NES. It's quite ugly. I did that like 5 years ago or so, just to put MIDI NES inside it. So you have, here I made RCA jacks that fed directly off the audio chips, and I have a MIDI jack here that connects to MIDI, the MIDI connector in the MIDI NES. But right now I just have a Pac-Man with a ROM. Anybody knows what an EEPROM is? An EEPROM is a special chip that you can program outside. So you actually put your ROM file or your data code, and the NES, instead of playing Pac-Man, will play whatever's on there. Underneath that, because I don't want to trick anybody here, there's another chip that I did, which is the character data. And since I didn't really care about what came on the graphics, I just used a D-pad to generate some sound. So I didn't put an EEPROM to change the graphics. So it's really a hacky Pac-Man garbled characteristic. That'd be interesting. So each time you have a console and you want to talk, and you have a sound chip that's directly in a console, you have no choice. Well, unless you want to spend lots of time wasted, you better start to learn the assembler of that particular console. So for each CPU, original CPU of these things, you have to learn that assembler. This is just an example of me driving the noise channel in the NES. So that you would compile in a ROM, put on the EEPROM, and do whatever you want with it. More obscure sound chip, the one in the Super Cassette Vision that I'm currently working on, it's not part of our products currently. So that's a more typical aspect you'd use. You need to have visual feedback of whatever variable you're actually sending the chip to play. So for instance, you would go and change param1 and see what it sounds like and analyze it, and then you'd say, well, what does parameter 4 do? And you do it both at once, so is there an interaction somehow? So it's, and you can take snapshots and tag your WAV files with whatever settings you have in there, so it's much easier to backtrack to understand what goes on. Of course, for the basic machines, you have the power of having a keyboard directly, so it could be very easy in the case of the +4. I just learned the commands to talk to the chip and type the proper pokes or whatever. This is the example for the VIC-20. Much lower resolution. It's very easy. Just 2 pokes and I got the noise pattern analyzed. This is my favorite approach for many reasons. This is a breadboarding for the pokey. I remember well. Initially, you'd probably do a breadboard, protoboard. Everybody knows the difference, huh? Basically, you start with a breadboard, put your chip on it, and try to hook it up and basically get to a point where you can write, do registers right on it. My preferred method of writing to chips is using this MIDI box setup, because it's the first thing I've got into originally, because I made a MIDI box SID in the fan. So you put your custom code in there through MIDI using SysEx, and depending on the chip that I want to target, I actually use multiple channels of aftertouch, and I just package my bytes in MIDI. So from the moment that that's done and I know it works, I can just with Max MSP, in my case I use this Darwin stuff, I could, or custom programs, could just program as if I were talking to the chip directly through MIDI. So sometimes it's more easy that way. So you only have to write this once compared to doing it directly with an EEPROM on original consoles. So you can do all your tests separately using Microsoft Visual C++ like I use. And so you program once and you can talk to all the chips. They just, depending on which chip I want to analyze or verify some things I've forgotten or didn't know properly, I just change the breadboard or protoboard and send new commands to it, and my pick code is already